Okay, Kipsters will be able to add and subtract numbers in scientific notation. So we talked about multiplying and dividing the other day. One thing that we know about this is that there is a big difference between how we add and subtract numbers that have decimals in them and how we multiply and divide them. So when we add and subtract numbers that have decimals, what do we have to do? Add and subtract decimals. What do we have to do, Jaquan? Yeah, we have to line up the decimals. Now we got to be really careful. Say I have something like 1.2, or let's go 2.4 times 10 to the second power, and 1.2 times 10 to the fourth power. So when we think about this, our initial thought is, oh, line up the decimals. I line this up, and then you're probably like, well, what do I do with these? You're probably like, I can just go ahead and add the exponents. All right, and that seems to be what we would think would make sense. That's our gut reaction, all right? But what we have to think about is, what do these numbers actually represent? Okay, so this number over here represents 240, and this number represents 12,000. Now, suddenly, did the way we line up those decimal places seem to make any sense? Kip, yes or Kip, no. Did the way we lined up those decimal places when I did this the first time, did that make any sense? No, because the decimal place is really here and here, and so we need the hundreds place to line up with the hundreds place, the tens place to line up with the tens place, the ones place to line up with the ones place. So realistically, we needed this all to line up like this: 12,240. Definitely not the same thing as 3.6 times 10 to the 6th power. So this is absolutely wrong. And so the way that we're going to make sure that things are lined up is we don't really want to have to get into the habit of taking these numbers and expanding them all the way out, especially when we've got decimals around the same place. But we know if we have the same number of multiplications of 10, then everything should line up the way that it's supposed to. So the first skill that we have to learn today is how to take a number and that's in scientific notation and take it out of proper scientific notation to give it the same place value, same multiplications of 10. Yes, Jaquan? Yeah, so over here, we were looking at, he's looking at this and he's saying, well, I want to make one of these a 10 to the 4th. I either want to make this a 10 to the 4th, or I want to make this a 10 to the 2nd. That's actually what we're going to be working on. All right, so when I look at this, I have 1.23 times 10 to the 4th. And I want to say, well, how would I write this as a 10 to the 5th power? And so we have to think about, what do we need? We need to add an extra multiplication of 10 at the end, but we can't change the value. So really, if I have this kind of goes into our idea here, 1.23, and I need 10 to the 4th to be multiplied. I need one more multiplication of 10, but I can't change the value of the number. If I can't change the value of the number, what do I need to put in that box? If I don't want to change the value of the number, what do I need to put in that box? Adrian? Yeah, 110. So this is almost exactly like the process of putting a number into proper scientific notation that's not. It's the same thing when we take it out. So now I have this 1/10 times 1.23. How is that going to move the decimal? 1/10 times 1.23. How is that going to move the decimal? 1/10 times 1.23. How is that going to move the decimal? Yeah, it's going to move it to the left, so that's going to make this 0.123, and this 10 times 10 to the 4th, that's just 10 to the 5th. And so our answer here is that if we were to put this in times 10 to the 5th, it'd be 3. All right? So over here, we've got a similar concept, except we're trying to move it down. So I've got 1.23. And I need it to end up to be 10 to the third. And so really what I'm going to be doing is I'm going to taking one of the 10 to the, I'm going to take one of the 10 to the fourth and I'm going to take it out. So this is really my 10 to the fourth. And now I'm just going to combine it over here with this number. So again, this is almost exactly like the process that we had for changing numbers into proper scientific notation when they weren't. It's almost the exact same process when we're bringing it out. We just have to think about how can we break this apart. All right. So I'm going to end up here with 1.23 times 10. That's going to give me what? 1.23 times 10, Sammy? Yeah, 12.3 times 10 to the third power. Now again, we're getting to the point where I have a feeling a lot of you are sitting here trying to memorize rules exactly the way I told you not to last week. It's the same deal here. Whether we're trying to put things in proper scientific notation or we're trying to switch them so they have a certain multiplication exponent for 10, we don't want to memorize rules because there are going to be so many different things that can happen here. Let's come over to this one. It says 1.23 times 10 to the fourth, and I need it to be times 10 to the sixth. So if I want my exponent over here to become 10 to the sixth, how am I going to get 10 to the fourth to become times 10 to the sixth? Trying to memorize a rule. How am I going to get 10 to the fourth to be 10 to the sixth? Yeah, I need two more 10s in here to become 10 to the sixth. So I have 10 to the fourth, and I need two multiplications of 10. Now here's the problem. I have two multiplications of 10 that I've just randomly added in there. That's going to change the value. So what is it that I need to put in this box? That's going to help me keep it from changing the value. Lola.
Times 1/10 times 1/10.
Yeah, times 1/10 times 1/10. So now I can put all of this together over here. That's going to give me my 10 to the sixth. And I'm going to put this multiplication over here. I have 1.23 times 1/10 times 1/10. 1.23 times 1/10 times 1/10 is what? 0.0123. All right? So this tells me this should, if I wanted this to be 10 to the 6, 0.0123. Let's do another one. I need to change this one to 10 to the second. So I have 10 to the fourth, and I need to get to 10 to the second. What do I need to do to 10 to the fourth to get it down to 10 to the second? I need to add 10s or take away 10s? Yeah, I need to take away 10s. So I'm going to take two of those 10s away. I'm just going to move them over here so they can be associated here with the 1.23. 1.23 times 10 times 10 is 123 times 10 to the second power. Do not try and memorize rules here. I can tell you for absolute certainty, maybe you'll remember the rule tomorrow, maybe you'll remember the rule next week, but if the only way that you know how to do this is by the rule, I can tell you in 2 weeks, you will have no idea. Giselle. All right, so looking at this, we started with a 10 to the fourth, and we needed to change it to a 10 to the sixth, which means we needed two extra multiplications of 10. But we can't just add extra multiplications of 10. They've got to come with their counterparts so it becomes a multiplication of 1. So when we multiply those 1/10 with the 1.23, that moves the decimal to the left. Okay? I have a 10 to the negative 4th. I need to change it to a 10 to the negative 5th. So I need an extra what? What do I need an extra multiplication of?
1/10.
Yeah, I need an extra multiplication of 1/10. So I'm going to throw in that extra multiplication of 1/10 times my 10 to the negative 4th. Because that's going to give me my 10 to the negative 5th. But when I do that, what do I need to balance out that extra 1/10 that I threw in there? What do I need to balance that out, Tarak? Oops. So we need a 10 to balance out that 1/10 that I had to add in to get to 10 to the negative 5th. So 1.23 times 10 gives me 12.3 times 10 to the negative 5th. Move over to the next one. I've got to get from 10 to the negative 4th from 10 to 10 to the negative 3rd. So am I going to be adding to my box of 10s, or am I going to be taking away from my box of 10s? In fact, they're not even boxes of 10s. They're boxes of what?
1/10.
Yeah, boxes of 1/10. So I need to take away a 1/10. So this is going to be 1/10 times 10 to the negative 3rd. 1.23. And so I don't need to add a multiplication of 10 in here to balance, because all I really did was split this apart. 1.23 times 1/10. 1.23 times 1/10. Ayla? 1, 2, 3. All right, so same thing over here. 1.23 times 10 to the negative 4th. I need to add 2 extra multiplications of 1/10 in here. So I've got 1/10 times 1/10 times my 10 to the negative 4th that I started with. But I can't just add in those multiplications of 1/10, so I need to balance them. What do I need to balance them with? How many multiplications? 2 multiplications of 10. So I'm going to combine this, 1.23 times 10 gives me the 123 times 10 to the negative 6th. All right, last one. I have 10 to the negative 4th, so do I need to take away from my box of 1/10 or add to my box of 1/10? Yeah, we have to take away from it, so I'm going to take away the 2 1/10. So it'll be times 10 to the negative 2nd power. So we have these multiplications, 1.23 times 1/10 times 1/10, so that means that moves the decimal twice, 0.0123 times 10 to the negative 2nd power. So what is the point of all this? Well, the point of all this is so we can have those numbers line up. When we want to do addition or subtraction, we have to have the same multiplications of 10. So coming over here, we're looking at this one. We have 2 different sets of multiplications of 10, which means that if I line up the decimals as they are, they're not actually lined up. All right, so I've got to find a way to make these decimals the same. So for me, I'm looking at this and I'm thinking to myself, well, what I probably want to do is I probably want to make them all to the largest 10. So I'm going to take this number right here, and I'm going to change it so it is 10 to the 4th. So I'm going to take that, I'm going to take my 3. I know that if I need to make it times 10 to the 4th, do I need to add to my box of 10s or take away from my box of 10s? If I'm going from 10 to the 2nd to 10 to the 4th, do I need to add to my box of 10s or take away from my box of 10s? Add to it. So I have 2 multiplications of 10 that I'm going to add in here. But I can't just add in multiplications of 10, so I also need to add multiplications of what to balance? 1/10. All right, so this is going to give me 0.12 times 0.3 times 10 to the 4th. So we have 1.2 times 10 to the 4th minus 0.03. So now I can do the subtraction by lining up the decimals. So I've got, not 12.2, 1.2. I'm going to take the 1.2, and I can subtract away 0.03. I need to fill in my spaces here. That's going to give me 1.17. Times 10 to the 4th. If you want to think about why this happens, you can think about this in terms of factoring. It's kind of like factoring out and having this be 1.2 minus 0.03, but they factored out times 10 to the 4th on the outside. Okay? If you want to think about why that happens, you can think about factoring. Yes, sir? We're going to find that sometimes we need to add more multiplications of 10 or multiplications of 1/10, and we can't just add them in there. We've got to balance them. All right, so when we look at this, this gives me 8 times 1/10 times 1/10, which is 0.08 times 10 to the 8th power. Now we have 6.4 times 10 to the 8th. Plus 0.08 times 10 to the 8th. And again, we can think about this in factored form. This is like 6.4 plus 0.08 times 10 to the 8th. So that's going to give me 6.48 times 10 to the 8th power. Yes, sir. So once I fix them, that moves the decimal 2 times. That gives me 0.012 times 10 to the negative 2nd power plus 3 times 10 to the negative 2nd power. So what you'll find is that it's almost always best to change your exponents to have the highest exponent. Because what we're going to see here is when we add 0.012 plus 3 times 10 to the negative 2nd. We're going to get 3.012 times 10 to the negative 2nd. So we're in scientific notation, correct scientific notation here. That will happen far more often when you change your exponent to be the largest exponent. Okay? We have another one over here with the negative. All right, so looking at this one, my larger exponent is my negative 6, so I want to change my numbers to negative 6. So that means I need to change this one. Do I have too many multiplications of 1/10 or not enough multiplications of 1/10 over here? Too many, so I'm going to push 2 of them out. And that's going to give me 0.08 times 10 to the negative 6. 6.4 times 10 to the negative 6 minus 0.08. So that's 6.4 minus 0.08 times 10 to the negative 6. Do your subtraction off to the side, line up those decimal points. It's going to give me 6.32 times 10 to the negative 6. All right, down here, now I've got a division. Do I need to worry about making my exponents the same if it's division? No, because essentially making our exponents the same is making sure the decimals line up. We don't have to do that when we're dealing with multiplication. So I have this 5.2, and this is just our rules. 5.2 divided by 4 is 1.3 times 10 to the 4 minus 12 gives me 1.3 times 10 to the negative 8. So this is really just one to be thrown in there to make sure that you're thinking about some of your other rules and that you're not applying the same rule to everything. Here I have a multiplication. Do I need to make sure that they have the same? Do I need to make sure that on the multiplication that they have the same exponent? No, just like we have decimal multiplications, same thing here. I'm just going to rearrange it. 2 times 3.14 times 10 to the negative 4th times 10 to the negative 2nd. Just using a little commutative property there. Then we can use the associative. 2 times 3.4 is 6.8. And we have 10 to the negative 4th plus negative 2nd gives me 6.8 times 10 to the negative 6 power. Alright, so multiplication and division are a whole heck of a lot easier because you don't have to worry about making sure that they have the same exponents first.